atomic number of element, if it is more than 92, that is of uranium, those elements are called transuranium elements, and the elements which are having atomic numbers more than 100, those are called transfermium elements. Now, there are some rules, there are some word roots we have to know. After that, we can give the IUPAC name to these elements. First, we have to learn that. We will take an example and we will do step by step, right? So, let's start with the digit 0. Now, 0, the Latin word is nil and its abbreviation is N. So, 0 is represented by nil and its abbreviation is N. Similarly, 1 is un and its abbreviation is U. For 2, it is bi and abbreviation is B. For 3, it is tri, abbreviation is T. For 4, it is quad and abbreviation is Q. For 5, it is pent and abbreviation is P. For 6, it is hex and abbreviation is H. For 7, it is sept and the abbreviation is S. And for 8, it is oct and abbreviation is O. And for 9, it is N and the abbreviation is E. Now, how to use these abbreviations? Let's take an example. Now, if the atomic number is 101, now what we will do? Now, this one, the first one is un. For 0, we will write nil. And again for 1, we will write un. And it is by default, we will write em. Em we will use in all the names, right? So, the symbol of the element will be U, N, U. Un, nil, anium. U, N, U. This U is for 1, N is for 0 and U is for again 1. Similarly, for 102, it is un, nil, bi and again em. So, un, nil, biem. U and B. 103, un, nil, trium. 104, un, nil, quadium. And similarly, it will go on like 105, un, nil, pentium. 106, un, nil, hexium. 107, un, nil, septium, and so on. So, like this, we can find the IUPAC name of the element having the atomic number more than 100. Now, guys, there is one more very important question as per the aspect of the board examinations and the competitive examinations. And that is, if an atomic number is given to you of an element, and if they ask in which group and which period and which block it belongs. So, there are some rules and we have to follow those rules, then we can find out if an atomic number is given to us, we can find in which block, which group and which period it is present. And the methods to find the period, group and the block of a given element are, the first one is what we have to do. First, we have to write down the electronic configuration, right? How to write to the electronic configuration we have discussed in chapter number 2, right? Then, after writing the electronic configuration, the period is given by the principal quantum number of the valence shell. We will take an example for that, right? So, the period is judged by the principal quantum number of the valence shell. Now, if we talk about the block is judged by the subshell which is being filled. If it is P1 or P2 or P3, means it belongs to P block. If it is D1, D2, D3, D4 or something like that, means it belongs to D block, right? Now, for group, there is the rule that we have to find out the number of electrons present in the outermost subshells or the penultimate shell, right? So, for different blocks, there are different rules And what are those rules? Let us understand. Now, in case the element belongs to the S block, if it belongs to the S block, the number of electron present in the S subshell will be the group number. And if it is present in P block, then we have to add number of electrons present in S subshell, P subshell plus 10. And if it is present in D block, then we have to add number of electrons present in S subshell and D subshell. So we can write in this way also, block, and if we have to find out the group, then the number of electrons, if it is present in the S block, then only for S subshell. If it is present in the P block, then number of electrons present in P and S and plus 10. And if it is present in D subshell, then it will be equal to the number of electrons present in S subshell plus the number of electrons present in D subshell, right? Let's solve a problem based on it. So guys, let's solve the problem. Now, in this question he is asking, write the electronic configuration of the element having atomic number 16, right? Also predict the period, group and block of that element. Now this question is very, very important as per the aspect of your school examination as well as competitive examinations. Now, let's see the solution. First, what we have to do, we have to write electronic configuration. And the electronic configuration is, now let us suppose the element is E and it is having the atomic number 16, right? Now the electronic configuration will be 1s2, 2s2, 2p6. So 2 plus 2 plus 6 is equal to 10. 3s2 and 3p4, right? So this is the electronic configuration. Now, whenever this question comes, you have to find out block first. In this electronic configuration, we can clearly see the last electron is present in P subshell and this is P4, and after this P5 will come and P6 will come. It means that this element is present in P block. So the block is P. So P block. So it is P block, right? Now the period. So what was the rule for period? Rule was the principal quantum number. So the maximum principal quantum number here is 3 because it is 3p4. So the period is third period. Now the group. For different blocks, we have the different rules, and we know that if the element is present in P block, what we have to do? We have to add the number of electrons present in S subshell, P subshell and plus 10 of the valence shell, right? So for group, what we have to do? We have to add the number of electrons, number of electrons in S subshell, P subshell and then we have to add 10, right? So it will be equal to, how many electrons are present in S subshell? In the valence shell, it is equal to 2. So we will write 2 over here, plus in P there are 4, and then we have to add 10. So it will be equal to 16. It means that the group number is 16. So P block, third period, and group number 16, right? Let's solve one more question.